Alright everyone, happy Tuesday, March 9th. I'm going to try to make this video shorter. Towards that end, I've done part of the lab and gone ahead and put down some questions, which you can see here. So if you're looking for answers, you can pause this video and there are the answers in red. But basically what we're going to do is I'm going to do the lab. You can do it too if you want to click here. It's a little complex. I'm going to do the lab. You're going to watch me do it and answer these and more questions that we get as we move along. Alright, so I'm already prepping for question number 5. And then we will jump into the video. Or into the lab, rather. Alright, great job so far. Anyhow, where am I? Oh, that's right. Let's go on.
Welcome to the lesson, How Can We Measure the Impact of Non-Renewable Energy? In this lesson, you'll investigate the effects of burning fossil fuels in everyday activities. What do sunlight, gasoline, and coal have in common? They are all energy resources, natural resources we use to generate energy. This circle graph shows the percent of energy the United States gets from different energy resources. Click each energy resource symbol to find out what it is. Then, drag each energy resource to its correct place in the graph and click OK.
It says I can click the energy resource to find out what it is, but I don't actually think I can. Oh, look at that. It'll say coal. Let's see. So this one's a little difficult because it's kind of a guessing game. But this is oil. I think oil is either the most or second most. I would say coal is probably second most. And then is this natural gas? Actually, natural gas is probably the most. I don't know, actually. Oil. I can't remember how these go. So I'm going to guess. Hydroelectric, probably pretty high. Of these 4, we got nuclear, geothermal, solar, wind. I'm going to say geothermal, solar, wind is next highest. Let's say nuclear is probably pretty low. Biomass, okay, try that.
Quite. Try it again.
I got one right, great. Okay, so I'm going to put these 3 over here. I want to swap them like this, this, because these are the 3 big ones, I'm pretty sure. I just don't know the order. And then I want to swap this one up here. I want to swap this one right here. Okay, that's it. Why did it take them out? I'm so confused. Now I lost my order. No. Alright, anyways. So basically this is like a guessing game here, which is why.
Job. Most of our energy comes from fossil fuels.
Okay.
Oil, natural gas, and coal. About 10% comes from nuclear power, which requires uranium. Fossil fuels and uranium are non-renewable resources. They are used much faster than they can be replaced. We get about 8% of our energy from renewable resources. These include moving water, plants, sunlight, wind, and geothermal energy.
So 8% is these 3. It's a little 8%. 10% is this guy. And the rest is really these guys.
You might not have thought about it, but you've probably already used fossil fuels today. Which of these things usually rely on fossil fuels? Click all that apply, then click OK.
It's all of them, guys. These 3 use energy that comes from the power plant. This one uses gas from the school bus. I was doing this earlier, and the video quit on me, so I know it.
Fossil fuels form from the remains of plants and animals that lived long ago. Chemical energy from these organisms is stored in fossil fuels. Click the images to learn more about each one.
Alright, let's learn about them. It wants me to click on coal first, I guess.
Coal is a dark rock formed from plants buried under swamps millions of years ago. When coal is burned, it releases heat. This heat is used in power plants to generate electricity.
I just wanted to highlight that question over there.
Oil, or petroleum, is a liquid that formed deep underground from ancient ocean plants and animals. When oil is burned, its heat can power engines. Oil is used to make fuel for cars, trucks, airplanes, and other machines. Natural gas formed from tiny marine organisms and can also form in rock and organic matter. When natural gas is burned, its heat can fuel stoves, water heaters, and furnaces to warm homes. It's also used to generate electricity. Fossil fuels provide different kinds of energy. They are generally easy to find and easy to store. And natural gas and oil can be transported long distances through pipelines. But fossil fuels have disadvantages too. As you've learned, they are non-renewable, so there is not an unlimited supply. What are other disadvantages? Click all the answers that apply, and then click OK.
So a lot of science is geared in this area towards showing people and educating people on kind of the negative effects of fossil fuel, which is an important thing to know. And I think we should strive to grow our other energy sources. But right now, they're the cheapest and most readily available, which is why they're really used so widely right now.
You're close. Try again.
Oh, they changed them up. I didn't even read them. That's kind of hilarious.
Fossil fuels provide different kinds of energy. They are generally easy to find and easy to store. And natural gas and oil can be transported.
Okay.
You got it.
I misread it. I didn't know.
In fact, fossil fuels are relatively inexpensive, but they can be harmful to the environment. In this lesson, you'll explore one of these problems, the emission of carbon dioxide, a greenhouse gas. Scientists are concerned that rising levels of greenhouse gases are contributing to global climate change.
All right, let's continue. That's what we want to learn.
You depend on fossil fuels every day, whether you're riding a bus to school or watching TV. Unless you're using a renewable energy resource, transportation and electricity require burning fossil fuels. In this activity, you'll investigate the amount of carbon dioxide produced each year through many everyday activities. Here's what you'll use. A fossil fuel calculator. You'll estimate how far you travel each week by car, bus, and train. You'll see how many liters of fuel you use each week. Click to see the electricity inputs.
We'll come back to this.
You'll estimate how many hours a week you use each of these electronic items. You'll see how many kilowatts of electricity you use each week, a data table. You'll record your weekly energy use, annual CO2 graphs. You'll see how much carbon dioxide is released by those activities in both mass and volume in 1 year. You'll see how much CO2 comes from burning fuel for transportation, generating electricity, and both. To think about this mass in another way, you will see how many cows it would take to equal that mass. Then you will see the volume of that much CO2. And find out how many school buses you could fill with that volume. You will record the total mass of the annual CO2 you produce. A camera. You will also take a picture of your graph. You'll investigate the amount of CO2 you produce through transportation. Continue to see if your prediction is correct.
Okay, so that is where I'm going to go ahead and put that in. I think I just go like this.
What steps will you take to check the amount of CO2 you produce in a year through Check your plan. Did you set a goal and include these steps? Estimate the distance you travel by car, bus, and train, and the number of hours you use different electronic items each week. Record how much fuel and electricity you use each week. Record the mass of carbon dioxide released by those activities over 1 year. Take a picture of your graph. If your plan does not include these steps, you can change it. Once you've finished, click the next button to move on.
Okay, so I am hurting through this a little bit, but I know that I don't want the video to be forever long for you guys, so that's why I'm doing that. That answer right there is also recorded over here. That is what I'm going to do. I don't have all of these steps. I don't have to take a picture of your graph. They are trying to emphasize the importance of all the specific steps, but I just had the general ones.
Now it's time to begin your investigation. Start with your weekly fuel use. Estimate the distance in kilometers you travel each week by car, bus, and train. Multiply miles by 1.6 to convert the distance to kilometers.
All right, so I travel 320.
When you're done estimating, click to see how many liters of fuel you use each week.
I have 320 down as my kilometer total. I had a calculator to help me get that. I do not ride the bus and I do not ride the train.
Record this amount in your table.
What amount? Weekly fuel. 320? Oh, weekly fuel is 37. Okay. 37 what? Oh, 37 liters.
Estimate how many hours a week you use each of these electronic items. Enter the number of incandescent and fluorescent light bulbs you use. When you're done estimating, click to see how many kilowatts of electricity you use each week. Then, estimate the number of hours these lights are on.
Hours? I'm guessing these are the hours. Okay, so I'm going to guess they're on a total of 8 hours, 5 light bulbs, probably between school and home. Television, I don't watch television, but I do use my computer. I probably use my computer a total of about 8 hours, to probably about 10 hours a day. Yeah, because they don't have a phone on here. Video game console, I don't have one. Microwave, I doubt I use my microwave even 0.5 hours. 0.5 hours of microwave a day would be obscene. Well, I guess not really. I guess not. I probably have done that at times. All right, then estimate the number of hours these lights are on. Done. What do I do next? Just really want me to do this. Oh, if I click next, what do I do? I think I want to click calculate. But yes.
Record this amount in your table.
Okay. 6. Okay, great. Good. Okay, did that.
This graph shows the mass of the CO2 released by those activities over 1 year. Click each bar to see its value.
Okay.
Click to capture a picture of this graph.
I do want to do that.
Record the total mass of the CO2 released.
I think I click over here.
Click to see the volume of that much CO2.
Ah.
Click to find out how many big school buses that much CO2 would fill.
Thinks that much. I don't know. Something like this. Alright, I think I did something wrong, but I don't want to redo this video, so.
Click to see how many cows equal that mass.
Cows aren't on there. I think this one's a little confused. Alright, I'll take a picture of that. I'll click here, I'll take a picture of that, and I'll go on. Overall message.
Which of your activities produce the most CO2 over a year? Transportation or electricity use? Record your conclusions in the box and then click OK.
Actually, was it electricity use? Actually, no, it's transportation. Okay, I'll put questions over here later, but let's finish this up. Here's my mouse. Alright, clicked OK.
Your results will depend on your own actions, how much fuel or electricity you use. For example, every liter of fuel burned each week, driving about 9 kilometers in a car, releases about 140 kilograms of CO2 into the atmosphere in a year. And every kilowatt hour produced each week, watching TV for about 1 hour a day, produces about 34 kilograms of CO2 in a year. How do your conclusions compare to your prediction?
Alright, so I'm running out of time in the video. Basically, we want to answer these questions, and then you're good to go. Have an awesome Tuesday.